Now with my first question, notice how if I'm trying to find out what x is, that is to say how I cut that wire to maximize or minimize total area, I think the extreme values for x are 0 and 10, so technically speaking, this is not a local optimization question, just an absolute extrema question. And so to answer both questions at once, let's go ahead and build ourselves a function that describes total area. But I think the total area in question is really the area of the square plus the area of the circle. But now take a peek at the square root of side length is s. Is it not true that its perimeter is 4s? But the perimeter is actually the length of the wire used over here, whose length is x. So I think the perimeter is x. And so I think s, the side length, as an expression in x, is x force. Notice over here, the circumference of the circle can be computed by looking at 2 times pi times r, but the circumference is really that length right there, 10 minus x. So I think the radius of the circle in question can be expressed as 10 minus x over 2 pi. Now the way I compute the area of a square is just 4 times the side length. The area of a circle is pi times the radius squared. So I guess the area total is going to be 4 times s, which I think is just x itself. I don't think I said that very well, did I? I think I made a small mistake. Do you mind if I fix it? I said the area of a square is 4s. That's its perimeter. We already discussed that. My apologies. I'm trying to optimize area. I may have correctly ascertained what the area of a circle is, but I did not correctly ascertain what the area of a square is. It's really its side length squared. But its side length squared in terms of x is going to be 1/16 times x squared. Now, as far as r is concerned, I'll make a substitution. So I can give you this. Now look carefully at what I just did. I generated a function for the area as a function in a single variable, namely x. So if I'm trying to find the absolute extrema for the area over the interval from 0 to 10, then I need to evaluate this function at the endpoints 0 and 10, but also at any critical number between. Now I'm limited on board space, so can I just take this opportunity to find out what the derivative function is, then I'll deal with the endpoints. So differentiating to find critical points. Sorry, I think I misspoke. Differentiating to find critical numbers. They're not points, they're just numbers. I'll talk about critical points in multivariable calculus, Calculus 3 or Math 32 at Sierra College. May I stall to check my arithmetic? I think I like it. Now, I'm the one in front of the board doing all the work, and I'm a little nervous. I'm nervous that I might have made an arithmetic error. Do you mind if I just double check to see if, well, maybe not double check. Can I check to see if my answer is even reasonable? Pi is approximately 3. So my denominator is approximately 7. My numerator is close to 42. 42 divided by 7 is 6. And you know what? Having x to be 6 seems reasonable. So, albeit I still might have made a mistake, but at least it's a reasonable value. So everybody, I'm running out of board space. How about if I do this? I'll get rid of the basic geometry. Even the pretty pictures. I'll evaluate the area at the left endpoint, at the right endpoint, and at the critical number. Now, at the left endpoint 0, what do I generate as a numerical value? Is that 100 or is that a 25 over pi? Here too, if I'm not annoying you, can I just stall and take a break and double check my arithmetic? So 0 is 100. That reduces, I like it. Now at x equals 10, that term drops out. 100 or actually 25 over 4. Here. All right, you guys, if you don't mind, I cheat. Can I take this approximate, or this opportunity, I should say, to approximate, if I can find a calculator. I have no idea what the value is. So let's just get the x value first. 40 divided by 4 plus pi, in parentheses, 4 plus. Oh, I need my reading glasses. Yeah. However, that's not right. I can't see it. Pi. Okay, I think I've got it. I think. So, I don't know, you guys. Can I just assume my arithmetic's correct or my computation's correct on my calculator? 116 times, it's not. Oh my goodness. I made a mistake. My apologies. So 1 divided by 16 times this x squared. I didn't square it. Sorry for wasting your time. That sure was a waste. However, these just saying numerator, that denominator is smaller than this one, so this fraction is bigger than 6.25. All right, everybody, here I go. I'll answer my question finally. Sorry for fumbling with my calculator. So how should I cut this wire to minimize total area? I think I should cut it in such a way that x is that many centimeters. How should I cut the wire to maximize total area of those two figures that I created? I think I shouldn't cut at all. I think I should use the entire piece of that wire to transform into a circle, not a square. That'll maximize the total area. Again, sorry to waste your time with the calculator. I should have computed that in advance.